Here's number 62 from section 3.1. Suppose that the functions f and g and their derivatives have the following values at x equals 2 and x equals 3, and we have a table below of all of those values. We want to evaluate the derivatives with respect to x, the following combinations at the given values of x. So let's begin with part A. We have the function 2f of x, and we want to evaluate at x equals 2. So first, let's differentiate 2f of x. 2 is a scalar multiplier, so the derivative is 2f prime of x. We want to evaluate that at x equals 2, so we're after 2f prime of 2 this time around. So that's going to be 2 times, and we'll grab f prime of 2 from the table. So we look at the table where we have f prime of x and where we have a 2, and we find where the row and the column meet. We get 1/3 there. So this is 2 times 1/3 for a final answer of 2/3. We move to part B. Part B is f of x plus g of x. So the first thing we want to do is differentiate. And with a sum of two functions, the derivative is just the sum of the derivatives. So this is f prime of x plus g prime of x. And we want to evaluate on B at x equals 3. So that's f prime of 3 plus g prime of 3. So now we look at the table again, f prime. This time we go to the second row of 3. We have 2 pi. And then for g prime of 3, we've got a 5. So 2 pi plus 5, those are not like terms, so that's a final answer. We'll move to part C. We have the product of two functions, f of x times g of x. So by the product rule, we're going to have f of x times g prime of x plus g of x times f prime of x. On part C, we want to evaluate at x equals 3. So that's f of 3, g prime of 3, plus g of 3, f prime of 3. So back to the table, f of 3 is 3, while g prime of 3 is 5. And g of 3 is -4, while f prime of 3 is 2 pi. So it looks to me like the final answer here is 15 minus 8 pi. That takes us over to part D, f of x over g of x. So that's a quotient rule problem. So for part D, we will look at g prime of x times f of x. That's low d high. Actually, I put the prime in the wrong spot. So low d high, there we go, minus high. So f of x, d low, g prime of x. And that's all over the low function g of x quantity squared. Okay, we want to evaluate this at x equals 2. So I'm going to take a little shortcut here and just write on top of my x's with a 2. And let's see what we have from the table. So g of 2 is 2, and f prime of 2 is 1/3, minus f of 2 is 8, while g prime of 2 is -3, and that's all over g of 2, which is 2, quantity squared. So I'm looking at 2/3 plus 24 all divided by 4, and in part D, that comes out to be 37/6, 37/6. Next to part E, f of g of x at x equals 2. So we have not a combination, but a composition of functions. So that's a chain rule derivative. So the derivative there will be f prime of g of x times g prime of x. Derivative of the outside, keep the inside, times derivative of the inside. And we want to evaluate at x equals 2. So f prime of g of 2 times g prime of 2. So that gives us f prime of, well, g of 2 is 2 times g prime of 2. So f prime of 2 is 1/3. G prime of 2 is -3. So this is 1/3 times -3 for an answer of -1 on part E. Next up, part F. So we have f of x, our function, inside of a radical. That means we got to use a chain rule. I'm going to go power of 1/2 to the front with our inside function f of x left alone. Now that's to the power of -1/2 times the derivative of the inside, which is f prime. going to take the same shortcut I did on part D. We want to evaluate f at x equals 2, so I'm going to write on top of the x's. I've already done that, I guess, here with the 2. Well, now we have 1/2 times f of 2. There's the bell. F of 2 is 8 to the negative 1/2 power times f prime of 2 is 1/3. So that looks to me like 1 on top and then a 6 on bottom and a square root of 8 on bottom. And that then becomes 1 over 6 times 2 root 2. Root 8 becomes 2 root 2. So that's a final answer of 1 over 12 root 2. Just fit it in there. All right, so there's f. We move next to g. We have 1 over g squared of x, 1 over g squared of x. And I'm going to change that to g of x to the negative second power. Rather than a power of 2 on bottom, let's go negative second power on top. So by chain rule, then, this is a derivative, negative 2 to the front. Leave the inside g of x. Now that's to the negative third times g prime of x. And on part g, we're looking at x equals 3. So let's replace that with a 3 and this with a 3. So now that becomes negative 2 times, well, g of 3 is negative 4, and then that's going to be to the power of negative 3 times g prime of 3. G prime of 3 looks like 5, so times 5. So this now looks to me like a negative 10 on top with a negative 4 to the third on bottom. So that's negative 10 over negative 64, which looks to me like 5 over 32, 5/32 for a final answer. That was G. Let's go to part H. Part H is a square root of an f squared of x plus a g squared of x at x equals 2. So this is a fairly complicated chain rule here. I've got 1/2 to the front times f squared of x plus g squared of x. Now that's to the negative 1/2 power times the derivative of all of that on the inside. Well, the derivative of f squared of x is going to be 2f of x to the first times f prime of x, plus the derivative of g squared of x is going to be 2g of x to the first times g prime of x. And then I'm going to write on top of all of those x's with an x equals 2. And we've got a lot of plugging in to go from here. So that's a 1/2 times an f of 2 quantity squared. Well, f of 2 is 8, so that's 8 squared, plus g of 2 squared. Well, g of 2 is 2, so that's plus a 2 squared. This is to the negative 1/2 power. Then a 2 times an f of 2, so that's 2 times 8 times an f prime of 2, so that's times a third, plus 2 times g of 2. G of 2 is 2 times a g prime of 2. G prime of 2 is negative 3. And now it's all about the arithmetic of simplifying. And this, if you take my word for it, simplifies down to a negative 5 over 3 square root of 17. That is number 62 on 3.1.